Okay, now before you can find out the current that flow through the circuit, you must find equivalent. What do you mean equivalent? That means uh, I want to combine these two connect resistor which is connected in parallel and replace it with the resultant resistance. Okay, the rest still remain the same. Okay, now uh, so the first step is to find the resultant resistance uh, of these two which are connected in parallel. Okay, so if you can find the R, if let's say the R value is known and the voltage is known, then you can find the current that flowing through the ammeter. Okay. Now, so first thing is to find the resultant resistance. If if the resistor are connected in parallel, okay, resistor connected in parallel, the formula will be 1 over R. R is the resultant resistance across these 2 points here, across here and here. Okay, now it's actually equal to 1 over R1. The R1 is the individual resistance of resistor number 1. Okay, and then 1 over R2, which is the resistance of the resistor 2. But the formula doesn't stop here. You have the third resistor, let's say it's connect here, the third resistor in parallel with the other two, then you put it as R3, and the list can continue. Okay, so the formula normally we write it like that. I mean, it can be the fourth resistor in parallel, the fifth resistor in parallel. You can continue to do this. Now, in this case, let's call R1 is equal to 2 ohm, and then R2 is equal to 6 ohm. Okay, so therefore 1 over R is 1 over 2 plus 1 over 6. Since we don't have R3, so we neglect it. So this one become 1 over 2 times 3. Why? Because we want to convert this, the denominator of this to be same as 6 before we can combine the numerator. So this time 3 plus 1 over 6. This becomes 3 over 6 plus 1 over 6. They give you 4 over 6. Now you invert it in order to obtain the resultant resistance. Okay. Now, so it's 6 over 4, which give you 1.5 ohm. So in other words, the equivalent of that is actually equal to 1.5. Okay, this R, the, the resultant resistance is actually 1.5. Okay, now, so if you look at this circuit, things become very simple. You use this Ohm law, V equal to IR. Okay, V in this case is 12 volt. Okay, 12 volt, and then you have the resultant resistance, which is 1.5 ohm. Now, bring this over, I is equal to 12 1.5, which gives you 8 ampere. Okay, in other words means there is 8 ampere of current that flow through this circuit. Okay, so that answer for the part 2. This will be the part 1 answer. Now let's look at part 3. Uh, the current that come out from the battery is 8 ampere, will flow all the way until here, 8 ampere. Okay, it will split itself proportionally according to the the resistor that you connect in parallel. Okay, you split among into two. I mean the 8 ampere will split into two. Okay, if you add the two current that flow through here and here, it still must give you 8 ampere. Okay, now how do you find the current that flowing through, let's say, the 2 ohm? We call it the, sorry, this one we call it the I2. Then this one we call it the I6. I2 means the current flow through the 2 ohm resistor. Okay, I6 is the current that flow through the 6 ohm resistor. Now, to find I2, wait, before that, let's look at this. What would you expect? 8 ohm, 8 ampere to divide between 2 ohm and 6 ohm. Logically speaking, if you have less resistance, which is 2 ohm, more current will flow through here. Okay, the current will flow through here more. And since this 6 ohm, which is a higher resistance, so the current that flow through will be less. Okay, so I2 is actually equal to I and time the ratio of the resistance. So below is a sum of the resistance. So it's 2 plus 6. Now, since we say that this is 2 ohm, we would expect more current to flow through. So if you put 2 here, 2 ohm here, then 2 divided by 8, versus if I put 6 here, 6 divided by 8, the ratio will be bigger for 6 divided by 8. Okay, and this is what we expect because of the low resistance. So to get a higher I, so we put this as 6. So substitute 8 times 6 over 8, cancel, you got 6 ampere. Now, I6, the current that flow through the 6 ohm resistor will be either you take 8 minus 6 ampere, which gives you 2 ampere. Okay, or you can do it this way using this same thing. Okay, I time you see, because is the resistor is the resistance is 6 ohm, you expect less current to flow in. So you use the 2 over 2 plus 6. Okay, so this become 8 times 2 over 8, cancel off, you end up with 2 ampere. Okay, now if you add I2, okay, current 2 and current 6, between this and this, you will see that it's same as 8 ampere. Okay, the current at any one point, it must be the same. Okay, what teacher means is like that. Okay, let's say I1, let's say there's another current flowing through I2, let's say there's another current flowing out, which is I3, another current flowing out, which is I4. So whatever come in must go out. So in other words, I1 plus I2 must equal to I3 plus I4. Okay, so in this case, the in current is only one current only, okay, which is 8 ampere. Okay, but in a complex circuit, you have two current coming to the same point and go out from the same point. So this is how you equate them. Okay, this one can continue to add here also, can continue to add. Okay, that's it.